Welcome! My name is Raina Fitzgerald, and in this lesson we're going to look at functions. Let's start by creating a function box. So here I have my box, and so this box represents a box that performs a function on something. So we're going to feed in a value. And it's this value that we're feeding in is what we say it is the input into the function box. And the value that we're going to feed in is some x value, and it's a specific x value. So we'll say it's x sub 1. X sub 1, therefore, is our input. Now, something happens inside the function box to x sub 1, and the results come out as output, and the output is a specific y value. We'll call that y sub 1. So y sub 1 is our output. X sub 1 is our input. Something happens to x sub 1 inside the function, and the value is output into y sub 1. Our input, which is an x value, is our independent variable. Our output is a dependent variable. The output depends upon the input, which is the independent variable. The independent variable, or value that's fed in, that is the x sub 1, comes from a set of x values. So here's our x sub 1, and x sub 1 belongs to a set of x values where there's an x sub 1, possibly an x sub 2, an x sub 3, and so forth. This set of values represents our domain. So x represents the domain of all x values, and each x value can be fed into the function as input with an output of a specific y value. The output values are a set of values, y1, y2, and so forth, that correspond with the input x values. This set of values represents the set of all y values. These values are known as the range. So the entire domain, which is a set of unique x values, are fed into our function. They're operated on by the function, and the output is a corresponding y value for every x value, such that the output y values are the range. So we input an independent variable, and for each input independent variable, there is a corresponding output dependent variable. An important concept of functions is that each input value may only produce one output value. Let me give you an example. Here, imagine here's our domain. It's fed into a function, and the output is our range. So if our domain happens to be the numbers 1, 2, and 3, then 1, 2, and 3 are values that are input into the function. So 1 is input into the function, then it is operated on by the function, and then output into the range. So let's say that 1 maps to a 2. Then we input 2 into our function. 2 is also operated on by the function, and the output goes into the range. So let's imagine 2 maps to a 4. And then finally the last value in our domain is input into the function, it's operated on by the function, and its output value is fed into the range. Its value is 6. What we can see here is that each one of these values maps to a unique value in the range. 1 maps to 2, 2 maps to 4, and 3 maps to 6. This is a valid function. Let's take a look at another valid function. Here we have the numbers 1, 2, and -2 in our domain. So our domain consists of 3 values. When we map the 1 into our function, the 1 is operated on by the function, and the result is output into the range as a 1. So 1 maps to 1. When 2 is fed in from the domain into the function, 2 is also operated on by the function, and it is output into the range as the value 2. Now -2 is input into the function from the domain. -2 is operated on by the function, and the result is output into the range as 2. This is a valid function. Now you may look and say, wait a minute, -2 and 2 are both pointing to 2. That's valid. It's valid to have a value from the domain, or multiple values from the domain, point to the same value in the range. What is not okay is to have an input value from the domain produce more than one output value. Each input value should map to only one output value. We'll use the diagram below to demonstrate something that is not a valid function. Here we'll put the numbers 1, 2, and 3 into our domain. Now we'll take 1 and input 1 into our function. This is actually an invalid function. 1 is operated on by our invalid function, and the output from 1 is a 2. Now 2 is input into our function, which is an invalid function, and 2 creates an output of 4. Lastly, 3 is input into our function, and 3 is operated on by this invalid function, and it has 2 outputs. It points to 4 and also to 5. So what we have here is 3 is mapping to not only to 4, but 3 is also mapping to 5. This is not a valid function. The reason is that each input can only produce one output, and in this particular case, the 3 is mapping both to a 4 and also to a 5, which is illegal for a function. Let's look back up at our very first example of a function. In this example of a valid function, 1 is mapping to 2. And what we do is we write this as an ordered pair, where 1 represents an x value and 2 represents the corresponding y value. When we input 2 from our domain into our function, it maps to 4, giving us an ordered pair 2, 4. When we input 3, it maps to 6. giving us an ordered pair 3, 6. And if you think about this, the equation that represents this function is that y is equal to 2 times x. Here, when we input 1 for our x value, we multiply 2 times 1, and our output y value becomes a 2. When we input 2 into our function, the input 2 is multiplied by 2. 2 times 2 is 4, so y equals 4, which is why we get a 4 in the range. That gives us the ordered pair 2, 4. Finally, in our domain, our last value is 3. When we input a 3 into this equation, which represents our function, we're going to take 3, multiply it by 2, and we get a 6. So y equals 6. And that's the reason that the output when we input 3 is a 6, giving us the order pair 3, 6. Now let's look at our next example of a function where 1 maps to 1, and that gives us the ordered pair. When we input an x, we output a y. So our first ordered pair is 1, 1. Our second ordered pair, our xy ordered pair, is 2, 2. And our third ordered pair is negative 2, positive 2. This function is the function y is equal to the absolute value of x. So when we input the 1 from the domain into our function, we take the absolute value of 1, which is 1. Y is equal to 1. So our output becomes a 1, and we get the ordered pair 1, 1. When we input a 2, y is equal to the absolute value of 2, which is a 2, and that gives us the ordered pair 2, 2. When we input a negative 2, we have y is equal to the absolute value of negative 2, which is a positive 2, and that gives us the ordered pair negative 2, positive 2. So we can use equations to represent our function, or how we operate on our input, our domain, to get a specific output, which is our range. We don't always have an equation to represent our function. Sometimes our functions are simply direct mappings, but we want to be certain that when we are looking at a function, that each input value may only produce one output value. And we must be aware when we have an invalid function, as we have below, where our input value 3 is pointing to 2 outputs, because that's not a valid function. One output for each input. Let's look at graphing a function. Below, in red, we have a function. This function consists of 1, 2, 3 points, or 3 ordered pairs. The first point is when x is 1, y is 2. That's this point here. X is 1, y is 2. The second point is when x is 2, y is 3. X is 2, y is 3, right here. And our last point is when x is 3, y is 2, right here. Now this is a valid function. Now you may notice that 1 points to 2 and 3 also points to 2. Well, that's valid. We just have to make sure that each input on our x-axis, our domain, points to only one output. One way to check this is using the vertical line test. So let me draw a vertical line. Here I have a vertical line. The vertical line test says if you run your vertical line along the x-axis from left to right you should only touch one point of your function at a time. So here, notice that right now my vertical line is touching a point on the function. If I move my vertical line over a little bit more, I touch another point on the function right here. And if I move it over a little bit more, I touch another point on the function. So we would say that this passes the vertical line test because in this case, as I run this vertical line across my domain, I touch only one point of my function on this line at a time. Let's take a look at a relationship, such as the one we see down here in red, that is not a function. This relationship that we see right here is a function. But let's look at a relationship now that is not a function and one that fails the vertical line test. Here we have another relationship which gives us 3 points through 3 ordered pairs. The first ordered pair is 1, 3. That gives us the point right here, 1, 3. The second point is the point 2, 2, which is right here when x is 2, y is 2. The third point is the point 1, 2. That is when x is 1, y is 2. Let's check this with the vertical line test. If this is a function, as we run a vertical line across the domain on the x-axis, we should always touch only one point on the function. Here, where x is equal to 1, we are failing the vertical line test. Here I have my vertical line at x equals 1, but I'm touching the function, the red function, in 2 places, which means it's actually not a function. It's not a function. It is, in fact, a relation. Every function is a relation, but not every relation is a function. So, this, and let me just fix this. I say no function. This is not a function. On this last page, we're going to look at 2 relations. The first is y is equal to 1/2 x. The other relation is that y squared equals x. Let's look at the first relation. The question is this a function? And what we're going to do is we're going to use the vertical line test. We're going to take this blue vertical line and run it along the domain, the x-axis, to make sure that we touch our function always at only one place. And as I'm running this along, you can see that here I'm touching the intersection between my red relation and my blue vertical line is such that they touch always at only one place. So we can see, using the vertical line test, that y equals 1/2 x is in fact a function. So this is a function. Now let's try the next relation. In our next relation, we have y squared is equal to x. Using the vertical line test, if we run it across our input, our domain, or x values, initially we touch at one point. But as soon as we get into the positive values for x, we can see that our red relation and our blue vertical line are touching at 2 points. This means that our relation y squared equals x is not a function. So these both give us examples of how to use the vertical line test to validate if a relationship is a function or not a function.